So design and analysis of algorithms. This one, all these videos done by me, myself, Dr. M. Purushotham Reddy, Associate Professor and Head of the Department of CSC from Institute of Aeronautical Engineering, Hyderabad. Hi everyone from Institute of Aeronautical Engineering. Today we are going to discuss about space complexity and time complexity, and also how to calculate space and time complexity of any given algorithm. So first here, what is meant by space complexity? The space complexity of a program or algorithm is the amount of memory it needs to run a algorithm to complete completion of that running of the algorithm. The space needed by the algorithm or program, it consists of the components. The components are instruction space, data space. Data space, it also has two components. The components are space needed by constraints and simple variables of the program. Space needed by dynamically allocated objects such as arrays and class instances. Environment stack space. The environment stack space used to save information needed to resume execution of partially completed function. Instruction space. The amount of instruction space that is needed depends on factors such as the compiler used to complete the program into the machine code, the compiler options in effect at the time of compilation, the target computer. The space complexity of algorithm or program P is given by the formula S of P equal to C plus SP of I. C is a constant, SP of I is a instant space. Fixed space requirements C. It is independent of characteristics of inputs and outputs. It includes instruction space, space of simple variables, fixed size, structured variables, constants. Variable space requirements SP of I, it depends on the instant characteristics. That is also depending on number, size, values of inputs and outputs associated with I. Recursive stack space, formal parameters, local variables, return address. These are instance space. These are come under instance space. Now here we see one example algorithm. So in this algorithm, we calculate mathematical calculation of the given variables. Now here we see that here we'll take in this algorithm ABC of A comma B comma C, three variables will take, three parameters will take. Here we calculate this expression value. Now here you see that here this algorithm name, this is the heading of the algorithm. It takes zero step count space. This return function, in this return function we have three different variables, and also using the expression it takes a constant space depending on the variables types or variable type, it takes the space. So that's why here the space of this algorithm is constant. Hence SP of S of P equal to constant. Here that this algorithm space is equal to constant. Next we see another algorithm. The algorithm is algorithm for finding sum of n numbers. Now here you see that in this algorithm, here sum of A comma n, A represents array of size n. We enter n number of elements in that array, and we add all the n numbers, and we print that sum value on the screen. Now initially here you see that initially we will take S value 0.0. For repeating all the variables in the array, we write this for loop for I equal to 0 to n2. Now S equal to S plus A of I, and also return that some value on the screen. For example, here we see that suppose you enter n value is 5. So in now A of 5, that means here the array is size of 5 elements. We enter the 5 elements in this array. Suppose you enter that first element is stored in A of 0. Next element is stored in A of 1. Next element is stored in A of 2. Next element is stored in A of 3. Next element is stored in A of 4. So now here we store all these 5 elements in this array. Now here, initially we'll take S value 0. So next here, for I equal to 0 means 0th element. And also 0, n value is 5. So here for I equal to 0, I less than n, I plus plus. That is the meaning of this for loop. So this for loop meaning is for I equal to 0, I less than n, I plus plus. So initially I value is 0, 0 less than n value is 5, 0 less than 5, s. That condition is satisfied, s equal to s plus a of 5. S value is initially 0, a of 0 value is 2, 0 plus 2 value is 2. Next here again come back to for loop. In that for loop I value, now we increment the I value. Now I value is 0 plus 1 value is 1. So 1 less than 5, s. So 1 less than 5 means here 5 means again that condition satisfied. Again we add that value to s. Previously s value 2, 2 plus a of I value is 1, a of 1. A of 1 value is 3. 2 plus 3 value is 5. Now again come back to for loop. Again increment the I value. Previously I value is 1. Now I value is 1 plus 1 is 2. 2 less than n value is 5. 2 less than 5, that condition satisfied. So again we add this value to s. So s value is 5. 5 plus a of 2. A of 2 value is here 4. 5 plus 4 value is 9. So again come back to for loop and also increment the I value. Now I value is 3. 3 less than 5, yes. So now this value add to s. S value is 9 plus a of 3 value is 6. 9 plus 6 value is 50. 9 plus 6 value is 50. So again come back to for loop and add I value. Now I value is 3 plus 1 4. 4 less than 5, that condition is satisfied. So now add that a of 4 value to s. S value is now 15 plus a of 4 value 8. 15 plus 8 value is 23. Now s value is 23. Now again come back to for loop and also increment the I value. Now I value is 4 plus 1 value is 5. 5 is less than 5. No, the condition is not satisfied. Now we return that some value. Now that some value is 23. We print that value 23 on the screen. So in this way we are executing this algorithm. Now for this algorithm, now find the space complexity. So how to find the space complexity of this algorithm? Here we see. So now here we see this algorithm sum of a comma n. This is the heading of the algorithm. It takes 0 step count space. Next here this braces also it takes 0 space count. Now s equal to 0.0, it is a simple statement. It take only 1 step count. For loop, this first statement it is a simple statement. It takes 1 step count. But s equal to s plus a of I, it repeats depending on the for loop. Here this for loop, in this for loop 0 to n is there. That means this the s equal to s plus a of I. This statement repeats n times. So n times it store the value. So it takes n step counts. A return statement is a simple statement. It takes 1 step count. This braces it takes 0 space. Now this for loop and the statement below that one it takes n plus 1 step counts. N plus 1 plus 1, n plus 2 plus 1, n plus 3. Totally n plus 3 step counts it takes. It takes. That means the space complexity of sum of a comma n algorithm is n plus 3. Next to see some more example. So this is a recursive sum algorithm. In this recursive sum algorithm, recursively you calculate the sum of n elements in the array. So R sum of a comma n. If n less than equal to 0, if n less than equal to 0 means there is no elements, then return that sum value is 0. Else otherwise in that array we have more than 0 elements, then we calculate the sum value using recursive function. Now here you see, suppose we take n value is some 3. So we enter n equal to 3 means we enter 3 values in array. So in a of 0 we enter the first value. In a of 1 we enter second value. In a of 2 we enter third value. Now if n less than equal to 0, here n value is 3, that condition is not satisfied. So next we come to else condition. Return sum of a comma n minus 1 plus a of n. n value is 3. 3 minus 1 is 2. A of 2, up to A of 2, we add that one. So A of 2 we add means 4 plus 6 plus 8. 10 plus 8, 18. And A of n value is 3. So A of n value is 0 here. We add that one. Otherwise, we take here, we take these values from 1. A of 1, A of 2, A of 3. So A of 1, A of 2, A of 3 values we add, we get the sum value is 18. We return that sum value here directly. Recursively we add. We call one by one and we add that one. So now here in this algorithm, for this algorithm, now we want to calculate the space complexity. How to calculate the space complexity of this algorithm here? See, this heading of the algorithm, it takes 0 step count. Next here, this first brace, it also takes 0 step counts. This if condition, here we see that this if condition, if this if condition it executes, it is a simple statement, it takes 1 step count. Otherwise, now return sum of a comma n minus 1 plus a of n. Now here we see that it consists of array of size n and return address. 3 functions is there, generally a of n. So here a of n means n elements is there, and also the return function it repeats n plus 1 times, and also here 3 parameters is there, so it repeats 3 into n plus 1 times. This is the space complexity of this algorithm. So if here, if n less than or equal to 0, return 0.0, that means if this condition is satisfied, this return statement won't be executed. In that case, this value is if statement takes one step count, this return statement takes another step count. That means here, if this condition, if n less than or equal to 0 condition is satisfied, that step count is 2. Otherwise, that step count is 3 into n plus 1. Once again, listen. Here, how to get 3? This 3 into n plus 1. Here, this array consists of n elements. So for repeating this one, it takes n step count plus 1 step count for return. Here we have 3 elements. List means array, n and return function. So 3 into n plus 1 step count it takes. That means here this S of p equal to 2 whenever n is n less than equivalent to 0 or n equal to 0. Now here 3 into n plus 1 whenever n greater than 0. So this is the space complexity of this algorithm. Next, time complexity. The time complexity of an algorithm is the amount of computer time it needs to run the completion of the program. The time T of P taken by the program P is the sum of the compile time and the run time. The compile time does not depend on the instance characteristics. So T of P, we write it as C plus TP of I. It is combination of compile time independent of instant characteristics. A run time T of P depends on instant characteristics. Once again, listen. Here, time complexity of an algorithm is the amount of computing time it needs to run the program. The time complexity depending on compile time and run time. So write T of P, we write it as C plus TP of I. C is a constant value. See here, compile time, it is compile time independent of instant characteristics. SP of I or TP of I is the runtime. It depends on the instant characteristics. Time complexity is calculated in terms of program steps, as it's difficult to know the complexity of individual operations. Now here you see an algorithm, iterative function for finding sum. That means R sum. Already we discussed this program. Now here we see that first here sum of a comma n, array of a comma n elements. So enter that one. For I equal to 1 to n, do, and also we want to calculate some value of all these n values using this formula, sum equal to sum plus a of I. And also finally we return the sum. Using count method here we find the time complexity. Here we see that without count method also directly we find the time complexity of this algorithm. Here first we see without count method, next with count method. The heading of the algorithm, it takes 0 counts, 0 time count. This branches also it takes 0 count. Sum equal to 0, it takes 1 step count. It is a simple statement. Now here this for loop, it is a simple statement. It includes one time. Plus it repeats n times for the statement for the statements below this one. So it repeats n plus 1 times totally. Next here sum is under for loop. So for loop repeats n times means this statement also repeats n times and also it takes n time counts. Return is a simple statement. It takes 1 step count. Now here you see that n 2n 1 plus 1 plus 1 2n plus 3. So total it takes 2n plus 3 time counts. So once again listen. Here matching branches takes 0 step counts. Algorithm, name of the algorithm, that is the heading of the algorithm, that takes 0 step counts. Sum equal to 0. It is a simple statement. It takes 1 time count. For I equal to 1 to n. This for I equal to 1 to n 2, it is a statement. It takes 1 step count plus this for loop it repeats n times. So n plus 1 step counts. Sum equal to sum plus a of I. This is the statement under this for loop. So it repeats n times. It takes n time counts. And return sum, it takes a simple. It is a simple statement. It returns. So it takes only 1 time count. Totally 2n plus 3 time taken for this running of this algorithm. Now here, for the same algorithm, we calculate this time complexity using count method. Now here we see in count method here we write sum equal to 0 count plus plus. Now it is a simple statement. It takes 1 count. So initially count value is 0, 0 plus 1 value is 1 here. Now for I equal to 1 to n 2 count plus plus. Previously count value is 1. This for loop is a simple statement and also it repeats n times for the statement below this one. So totally it repeats n plus 1 times. N plus 1 plus 1. N plus 1 2 now. Now again sum equal to sum plus a of I. Again count value count plus plus. So this sum equal to sum plus a of I. It repeats under this for loop n times. So previously count value is n plus 2 plus n. That means 2n plus 2 now. Now again we come to return sum. So return sum here we see that it is a simple statement. It takes 1 step count. Already count value is 2n plus 2. Now plus 1. 2n plus 2 plus 1 is 2n plus 3. So totally this algorithm takes 2n plus 3 time counts or time step counts. This is the time complexity of this algorithm. Next, recursive sum algorithm. Now here we see that recursive sum algorithm or sum of a comma n. Recursively we calculate the sum value. First we calculate time complexity without using count method. Next we will discuss time complexity using with count method. So initially this is the heading of the algorithm. It takes 0 step counts. Branches takes 0 step counts. Now here we see here first we write here if n less than equal to 0. It is a simple statement. It takes 1 step count. Return state so takes 1 step count. If this condition is satisfied, this return will be executed. If this condition is not satisfied, this return will be executed. Now here we see that now t of n equal to 2 whenever n equal to 0. Whenever n equal to 0, t of n value 2. So n equal to 0, this condition is satisfied. So this condition satisfied means this return, second return function is not executed. Next we come to here. If this condition is not satisfied, if this condition is not satisfied means n value is greater than 0. Now, here we see that. If this condition is also not satisfied, it takes, this is a one step count. This here, return is a one function, that is one step count. That means 1 plus 1 is 2 plus how much time this function takes. This takes, it is a recursive function. It takes a sum of n minus 1 times. Here, sum of n minus 1. So 2 plus TR sum of n minus 1 times it executes. 2 plus TR sum of n minus 1 times it executes. So once again listen. So TR of R sum of a comma n. Now here, if n less than equal to 0, it is a simple statement. It takes one step count. A return 0.0 takes 1 whenever this condition satisfies. So T of n equal to 2 if n equal to 0. If this condition is not satisfied, then if condition is executed and also else condition is executed, it takes 2 steps counts. And also next return the R sum of a comma n minus 1 plus a of n. Then it takes a TR sum of n minus 1 step counts. Now here we calculate recursive sum of this value. Now here you see how to calculate this time complexity, this recursive function time complexity. Here you see. So T of n equal to 2 if n equal to 0, TR sum of 2 plus TR sum of n minus 1 if n greater than 0. Now recursively solve this this time complexity. TR sum of n minus 1 which is equal to, this is T of n. So 2 plus, this also is the form of T of n. TR sum of n minus 1 again 2 plus TR sum of n minus 2 and so on. So n minus 1 up to repeating one time. So 1 to n minus 1 means we're repeating n minus 1 times. And also totally 0 to n minus n equal to 1 to n times. Here 1 to n times means here 2 repeats n minus 1 times means 2 plus 2 into 2 plus and so on to n minus 1 times. Already this 2 is separate one. Plus TR sum of n value is 1, 1 minus 1 is 0. So this is n times 2, n minus 1 times plus 1 time, n times 2n plus TR sum of 0 value is how much here? 2, 2n plus 2. So in this way, we calculate time complexity of this recursive sum algorithm by using this method T of n equal to 2 plus TR sum of n minus 1. It is a iterative method. Using this iterative method, iteratively we substitute all these values and also finally we find the time complexity value. That time complexity value is 2n plus 2. Next, for the same algorithm, how to find time complexity of this algorithm using using count method. Here we see. So here count plus plus. Initially count value is 0, it takes 0 step counts. This if condition it takes 1 step count 1 and also this step count is 1. Now count 1 plus 1 is count value is 2. Suppose this condition is satisfied. Now TR sum of n value is 2 if n equal to 0. Otherwise this if condition is executed, after that one this else condition is executed. That if condition takes 1 step count, this else takes 1 step count, it takes totally 2 step counts plus this return or sum of this function takes n minus 1 times step counts. So TR sum of n minus 1. Already we solved this one. This recursive function iteratively and also already we get that value as 2n plus 2. So in this way, we find time complexity of this algorithm in two ways. One is without taking count method, with count method. In both methods, we get the same value. Next, another algorithm addition of two matrices. Now here we see how to find addition of two matrices time complexity. So add A comma B comma C. A is an array, B is another array, C is used to array to add these two arrays and also store that addition value in C. Rows comma columns. For I equal to 1 to rows, do this one for this for loop is used to repeating rows. This for j equal to 1 to column, do this is used for columns, repeating columns. Now C of ij equal to A of ij plus B of ij. Now here we calculate the sum value. Now here we see that here this for loop here, this is the first statement, this is the ending of the statement. It takes 0 step counts. Next, this for loop, it has a rows. It repeats how many times here we see. It repeats rows times. So 1 2 rows. So under this one, this for loop is there. For j equal to 1 to column 2, it repeats rows times and also columns times. Rows plus 1 times this one it repeats. So for loop 1 time and also rows times. So this repeats. The second for loop it repeats rows into columns plus 1 time. This statement repeats. Now how many times it repeats here? See, it repeats rows times as well as column times. So rows times as well as column times. So it repeats 2 into rows into columns. 2 into rows into columns. Otherwise rows into column times here. We add that one. Rows into column times. So here row times for this for first for loop. Column times for second for loop. Now we add all this. Rows plus 1. Rows plus 1. Plus rows into columns. Plus rows into 1 is rows. Plus rows into columns. Now rows plus rows, 2 rows, 2 into rows, plus rows into columns plus rows into columns, 2 into rows into columns, plus 1. So this is the time complexity of this algorithm. Even though using step count method also we calculate this time complexity, we get the same time complexity. Once again, listen for this how to calculate time complexity of this algorithm. So this ending of the algorithm, it takes 0 time step counts. This for loop it repeats rows times plus this for loop 1 time, rows plus 1 time. Next this for loop for j equal to 1 to columns, it takes columns plus 1 times. Plus it is under first for loop I equal to rows times, so it repeats rows times. This IC of ij equal to aij plus bij, it is under for I equal to 1 to rows columns do for loop and also for j equal to 1 to column do for loop. So it repeats for I equal with respect to I equal to 1 to rows, it repeats rows times. With respect to for j equal to 1 to column times, it repeats column times. So we calculate the complexity of rows plus 1. Columns into rows values, rows into columns, plus 1 into rows is rows, plus rows into columns. So rows plus rows is 2 into rows, plus rows into columns plus rows into columns is 2 into rows into columns, plus 1. So this is the time complexity of this matrix addition algorithm. Next, computing time complexity. complexity is determined by using table which includes steps for execution. That is about by which count changes as a result of execution of the statement. Now here you see this algorithm. So we calculate. So in this method we calculate using by tables. In the tables we write the execution time and execution of amount of time for each and every statement. Frequency, number of times a statement is executed, that one is called as frequency. Here you see the first algorithm, sum of n numbers algorithm sum of list comma n. Now initially will take some value 0.0 for I equal to 0 to n2, repeat that one, and also temp sum equal temp sum plus list of I. List of I means array of I elements and also return temp sum. For this algorithm, we find time complexity by using step for execution, and also frequency means how many number of times that that corresponding statement will be executed. Now here you see this heading of the algorithm. It takes 0 step counts or step for executions. This braces also take 0. This temp sum, it is a simple statement. It takes 1 step count. This for loop initially it takes 1 step count. Temp sum equal to temp sum plus list of I takes 1 step count. Return statement take 1 step count. Step for execution. So here step for execution we write only if the statement is takes some time or not. If it takes time, it will write 1. The repetition will write in frequency. So this brace takes 0. Now here 0 means here it won't takes any time for execution. Now we come to here. Temp sum equal to 0. It is a simple statement. It repeats only 1 time. Next here for the for loop, it initially takes one step for execution, and also it repeats how many times? N times. N plus 1 times it takes for execution. Next, this temp sum equal to temp sum plus list of I. It repeats under this for loop n times, so it repeats n times. Next, return sum, it executes only 1 time, 1. Now 0, 0, 1 into 1 is 1, 1 into n plus 1 is n plus 1, 1 into n is n, 1 into 1 is 1, 0, 0, 0. We add all these values. 1 plus 2n plus 1, n plus 1 is 2n plus 2, plus n is 2n plus 2, plus 1 is 2n plus 3. So the time complexity of this algorithm is 2n plus 3. Next one is a recursive sum of the given n numbers. So the algorithm is algorithm or sum of list of list means array of n numbers. N means n number of elements. If n less than equal to 0, then return 0. Otherwise, return sum of list of n minus 1 plus list of n. So repeating this one recursively, we are adding all the n numbers. Now here how to calculate time complexity of this algorithm. Now here this first the ending of the algorithm, it takes 0 step for execution. Brace also takes 0 step for execution. This n less than equal to 0, it takes one step for execution. Return takes 1 step for execution. Else takes 0 step for execution. This return takes 1 plus the sum of list of n minus 1 plus list of n, it takes n plus x. X is a variable value. It takes variable step count. Now here we write repetition values. So this if n less than equal to 0, it repeats only 1 time. Return repeats only 1 time. Else it repeats 0 times. This 1 plus x times it is a variable count value. So that's why here we write repetition value is 0. So if n equal to 0, it won't be executed. So it is 0. If n less than n greater than 0, it executes 1 time. This n less than equal to 0, that one also executes 1 time. Here 2 cases is there. If n equal to 0, n greater than 0. If n greater than 0, this if n less than equal to 0, that is executed 1 time. That condition is not satisfied means that corresponding return function is not executed. This return function is executed, that is executed 1 time. Now here we write total steps. If n greater than n equal to 0 and n greater than 0. N equal to 0, 0, 0. Here n equal to 0 means here 1. 1 into 1, 1. Next here, these values are zeros. If n greater than 0, so if n less than equal to 0 value, executed. So that value is 1. This R return or sum of list of n minus 1 plus list of n, that value is executed. So 1 plus x into 1 value is 1 plus x. 0. So here we observe that if n equal to 0, it repeats 2 times. If n greater than 0, it repeats 2 plus x times. 2 plus tr sum of n minus 1 or 2 plus x times. So right now that time complexity is tr sum of n equal to 2 if n greater than equal to 0, 2 plus tr sum of n minus 1 if n greater than 0. Now we recursively calculate this value by substituting the values and to find the time complexity. Now here we see how to find that one. So tr sum of n equal to 2 plus tr sum of n minus 1. 2 plus, again this tr sum of n minus 1, it is in the form of tr sum of n. So substitute that same formula 2 plus tr sum of n minus 2. And so on, it repeats n minus 1 times. So 2 plus and so on, 2, it is n times, including this 2, plus tr sum of n 1 minus 1 is 0. So it repeats 2 plus n times means 2n plus tr sum of 0 value is 2. 2n plus 2 is the time complexity of this recursive sum. Next, addition of 2 matrices. So this algorithm, we find addition of 2 matrices. A is I add A, B, C, M, comma N. A is one matrix, B is another matrix. This addition value store one more matrix. For that one, here we use C matrix, and it consists of A matrix consists of m number of elements. A matrix consists of m number of rows and n number of columns. Similarly, B matrix consists of m number of rows and n number of columns. Similarly, we add these 2 matrices, we get m number of rows and n number of columns. That is the size of C matrix. So for I equal to 1 to m2, this is for rows. For j equal to 1 to n2, this is for columns. Here we add a plus ij plus b of bij value and to store that some value in Cij. Now for this one, now we want to calculate time complexity value by using step for execution method. So heading of the algorithm, it takes 0 step for execution, braces take 0. This for loop initially it repeats only 1 time. This for loop it takes only 1 step for execution. This is a simple statement, it takes 1 step for execution. So how many times it repeats? Now find that frequency. So this for loop initially it takes 1 time and it repeats for the statement below this one, it repeats m times. So it totally takes m plus 1 times. This for loop it repeats 1 time and also it repeats for the statement below this one for n times. N plus 1 times. But this is under a for loop of ith for loop for I equal to 1 to m2. So it repeats m times under that for loop. So m into n plus 1. Then Cij equal to Aij plus Bij. Now here you see that this statement is under for loop, first under for loop for j equal to 1 to n. So it repeats n times. And as this is under the for loop for I equal to 1 to m2. So it repeats m times under this for loop for I equal to 1 to m2. So m into n times it repeats. So we are here total value. So 0 value 0. 1 into m plus 1 is m plus 1. 1 into m into n plus 1 is mn plus m. 1 into m into n value is mn. So now we add all these values. So m plus m, 2m. mn plus mn, 2mn plus 1. So the time complexity of this matrix addition is 2mn plus 2m plus 1. So in this way, we easily calculate the time complexity of any algorithm using step for execution and frequency method. Next, the time complexity of any algorithm We represent in three different cases. One is best case, another one is average case, third one is worst case. Best case means the minimum possible values or the minimum number of steps to find the time complexity or space complexity of the algorithm. Average case means the expected value of f of n. Worst case means the maximum value of f of n. The maximum step count of the function. That one is called as worst case complexity of the algorithm. Thanks to everyone.
Like, share and subscribe. Hit the bell icon for more updates.